everyone, my name is Doerrie from the ITE, Institute of Structural Design at the TU Braunschweig, and today I will present the new calculation approach for selecting and orienting the reinforcing material for robotic concrete manufacturing, which was written together with Abtin Baghdadi and Harald Kloft. Calculation for forces and the integration have been very general for the last 80 years. It is based on a handmade manual process, and it is often repeated for typical and simple construction elements. Thus, the rebar is mainly used as straight long steels and simple stirrups. However, this approach does not consider the time dependency of loads, and also dynamic loads open up new challenges for this process. With these boundary conditions, the reinforcement is always placed in a very general way, but also because it has to be manufactured by hand and placed on site by hand. But with the development of new production methods and reinforcement materials, also the calculation has to be rethought. Here we can see, for example, as a new technology, the 3D concrete extrusion, shotcrete 3D printing, or the robotic rammed earth construction. And as reinforcing materials, the wire arc additive manufacturing, carbon mesh reinforcement, or fiber reinforcement. And especially the time dependency of load cases should be regarded in this new approach. So a new approach to calculate and locate the reinforcement is needed. And today we want to introduce this new approach. As an example, we calculated a cantilever beam with a one-direction support in the middle and one fixed support on the side. The approach we are introducing is separated into 8 steps and uses solid mechanics calculation. Furthermore, it is focused on the geometry and time dependency of the load application, and the non-linearity of the material is regarded. The investigated load case works in 2 directions and, as shown in the table, is measured in different times during the application additional to a load change. For the finite element calculation, abacus was used, and the application of the shown load case was divided into 10 steps. Each second was transferred into MATLAB for an individual calculation, and 2 factors were mainly investigated, which are the amount of stress and type of stress. After we established the basis for the calculation, the material capacity was calculated. For example, the shear capacity was calculated based on the common use standards. In step 3, all mesh-based data are imported and sorted in the coding platform MATLAB from a datasheet. The stresses in the integration point in the mesh are calculated to convert a 3D element to a planar geometry. Step 4 consists of calculating the amount of stresses as well as the angles of the appearing stresses. For this calculation method, the Mohr circle is used, and because of the short time, I would kindly refer you to the paper if you're interested into more details. Here in the table, you can now see the results, see one part of the logical loop programmed in MATLAB for these 8 different possible scenarios. And as a basis from the previous steps, we now have the amount of stress and the capacity of the chosen material. These values are now compared. The table on the right shows the principal stress in 2 selected time steps. On the bottom, you can see the bending and shear forces in 2 different time steps. In continuing the process, we are now able to orient the reinforcement. The amount of existing stress and the allowable amounts regarding the material properties are compared to select the areas demanding the reinforcement in each time step. The left diagram displays the zone in which the absolute amount of shear is higher than the resistance of the concrete at T 0.4. The right diagram shows the angle of the trajectory lines for the same time in which the stirrups, rebars, should be located. These calculations are operated in nested loops by logical commands. And to illustrate the advantage of the proposed approach, the dynamic load is selected. The diagram shows the result of the shear on the left side and the tensional forces on the right side for the selected time increments. The shear column illustrates how the reinforcement should be located when the load is applied. And the final step implies the recalculation of the specimens. Since locating the reinforcement changes the stress distribution, all processes should be repeated with the calculated reinforcement, in which the amount of the calculated forces and the related dimension of the reinforcements are considered. The picture shows the beam's performance in which the calculated attentional reinforcement is regarded, and a carbon mesh reinforcement is assigned. So what can we take away from our study? The interfaces between the FE software, coding and logical indexing tools can successfully assist in innovative different calculation approaches. The proposed approach can efficiently be utilized for different types of geometries and loads, for example dynamic loads or freeform elements, and the proposed approach can be used for any types of materials with different properties, such as concrete with different reinforcing materials. So thank you very much for your attention and enjoy the rest of the conference. Thank you.